Hey guys, Mr. Middleton here. Today we're going to talk slope. At the end of this video you should be able to find the slope of a line from a variety of given information. Okay, starting off, slope is just like rate of change without a label. Okay, so with rate of change we really focused on making sure we understood what it was talking about. We will be able to do that if we can, but a lot of times we'll be on a coordinate plane, so there won't really be a label. But the concept stays the same. So slope is the change in y over the change in x. A lot of times you'll hear me talk about it as rise over run. Okay, so here's a related question. And we're going to talk about finding the slope between 2 points. If the temperature outside was 45 degrees and is now 58 degrees, what is the change in temperature? Okay, you can find change by subtracting, right? You'd say 58 minus 45, the change in temperature was 13 degrees. You might say positive 13 degrees because it went up. Okay, so, and you found that just by saying 58 minus 45. Well, if we have 2 points, x1 and y1 and x2, y2, what's the change in each coordinate? You'll answer the question. When you answer this question, you're finding slope. Okay, you're essentially doing the same thing you did with the degrees here, except now you're doing it with points. And the formula will be y2 minus y1 over x2 minus x1. Okay, trying to find the change in y over the change in x. Another way to write this formula is y1 minus y2 over x1 minus x2. In other words, it does not matter at which point you start with, but you must be consistent. And by that I mean, if you start with x1 or y1, you have to start with x1. Okay. Alright, so down here we're going to do these first two together. I'm going to leave this third one for you to do. I'll go really slowly through the first one, and the second one you'll do on your own. Or third one you'll do on your own. So, remember our equation is, and it really doesn't matter which one we're going to use, but I'm going to use this one. Especially at the beginning, it might be helpful for you to just label everything. Remember that x comes first in this ordered pair. Y comes second. Okay, so I have y2, which is 8, minus y1, which is 5, over x2, which is 9, minus x1, which is 3. So 8 minus 5 is 3, 9 minus 3 is 6, and my slope is 3, 6. Okay, but I won't use slope like that. Always want to simplify. 3 divided by 6, or 3 over 6 simplifies to 1/2. So my slope is 1/2. And M stands for slope, right? So my slope for that is 1. Okay, now I'll do this next one. Again, you don't have to do this all the time, but especially if you're having difficulty putting stuff in the right order, or just remember as you're going through the first data, remember here are your points. Like I said, it really doesn't matter which order you start with, but you do have to be consistent. So I'll call this x1. I'll start with y1 and x1. Just doesn't matter. So I'll say 2 minus negative 8. When I'm subtracting a negative, that means I'm adding. So 2 plus 8. Negative 3 minus 1. So 2 plus 8 is 10. Negative 3 minus 1 is negative 4. And then I'm going to simplify this. 10 divided by negative 4. I'm going to simplify my fraction. That gives me 5 over negative 2. Okay. remember that your answer needs to be as an improper fraction and not a mixed number. Improper fractions tell us that for this problem, we go up 5 and to the left 2 because it's negative. Improper fraction, or sorry, a mixed number, negative 2 and 1/2, doesn't really help us as much. Okay, so here's our slope. Remember to do that third one on your own, please. Flipping to the back. Finding slope from a table. Now, if you can find the slope from 2 points, you can find the slope from a table, because a table is essentially a collection of points. Okay, we have x, y, that's 1 point. X, y, 2 points. X, y, 3 points. X, y, 4 points. So we are given 4 points in this table. Different tables will give you different point values, or different number of points, but in this table we're given 4 points. And we only need 2. So we can find the slope by choosing any two points. If it's a linear relation, which you will be given linear relations unless I ask you if it is one, we can choose any 2 points. I'm going to choose these two because it has 0 in it, and I feel like that makes addition and subtraction easy. So I'm going to do y2, 6 minus y1, 12, over x2, 3 minus x1, 0. 6 minus 12 is negative 6. 3 minus 0 is 3. Negative 6 divided by 3 is negative 2. Okay, you can leave it as negative 2, or some people find it helpful to always leave it as a fraction. Remember, all whole numbers are a fraction over 1. All right, so again, do this on your own. Remember that those are just a collection of points. All right, so we found slope from points in a table, which is essentially points. And now we're going to find slope from a graph. Now remember at the beginning I told you that slope is change in y over change in x, or you can talk about it as rise over run. Graphically is when you use rise over run the most. Okay, this one is the most efficient. A lot of people get stuck in their ways, and then they try to find out what point this is, and they say, okay, well this is 0, 3, and this is 1, 3, and then they do the subtraction. It takes a long time to do that. With the graph, you can look at it and say, okay, let me see, should my slope be positive or negative? And so in graph 1, as you go from left to right, the line goes down. And so since from left to right the line goes down, you know the slope should be negative. And this is just a way to check that your answer lines up when you're done. And now you're just going to look at the rise and the run. So from this point to this point, how do we get there? Well, we went down 1, 2, down 2, so that's negative. That's a rise, so it goes on top. And then we went over to the right, 1, 2, 3. And that's positive, because to the right is positive, 3. And so here's our slope, negative 2/3. Over here, in our second graph, as you go from left to right, the line goes up. Okay, and so you know the slope should be positive. And again, we just count really our rise. So we go up 1, 2, and over 1. So 2 over 1. You can leave it as that, or you can make it a whole number. Either way. All right. I did not print these out in color, but I will say that this is the red line, and that this is the blue line, or green line. All right, so we're going to pick any 2 points from the red line. I'm going to pick the point here at 0, 3, and I'm going to pick the point here at 3, 3. Again, I could have picked any point, but I chose those two. And now I'm going to find the slope. So I have y2 minus y1, 3 minus 3, over x2 minus x1, 3 minus 0. So 3 minus 3 is 0. 3 minus 0 is 3. 0 divided by 3 simplifies to 0. A horizontal line will have a slope of 0. Okay, this is true of all horizontal lines. Okay, some people get mixed up on these words. Horizontal, I always think of horizon. Like if you look off to the horizon in the sunset, okay, horizontal. Okay, so horizontal will always be 0. Horizon has the sun, 0. Okay, if that helps you out any. All right, now, as we look at this green line, we're going to find 2 points. So I'm going to choose the point 0, 0 and the point 0, 2. So I have 0, 0 and 0, 2. All right, and then I'm going to find the slope. So y2 minus y1, 2 minus 0. x2 minus x1, 0 minus 0. So I get 2 over 0. If you type that into your calculator, you will get a domain error. Okay, and that's because we can't divide by 0. Can't put something in groups of 0 evenly. Okay, and so what happens is any vertical line, we have an undefined slope. Every single vertical line, we have an undefined slope. Okay. All right, so you should be able to find the slope using 2 points, a graph, a table with vertical lines and horizontal lines. See ya.